So hyperbolas, the equation for the standard form of a hyperbola, and we're going to start today again, just like we have been, by starting everything at the origin. The reason why I want to not fly through the hyperbola is that I want to really attack the idea of, there's one little fancy part of hyperbola that is really kind of cool that I make you guys do that you don't get a lot of. So, hyperbolas look like this. Or like this.
We have two equations.
No, it's still one equation. Hyperbolas look like that. It's basically two parabolas. What's happening in between them is that there's values that happen. You still get vertices, you still have foci, and you still have, they're not technically called covertices in a hyperbola. I call them still covertices because they're the value of b. And you still have a center. The center is going to be in the middle of all of that. Okay? Today we're going to talk about stuff being centered at the origin. And the difference between the hyperbola equation versus the ellipse equation is very, very subtle. Hyperbola equations look like this. X squared over a squared minus y squared over b squared is 1. It's a minus sign. And now, the a and b values don't matter as far as which one's greater. Okay? That won't matter. What matters is what comes first, x or y. So a vertical one is when x comes first. Yeah. And then they just switch over to the actual, this is a fancier way of looking. The equation is, the, the vertical axis, sorry. So if x squared comes first, it's doing this. If y squared comes first, it's the up and down. I'm sorry, I rephrased that incorrectly because that talks about the way the axis goes, okay? So it's a little bit different. Now, what A, B, and C still stand for, A is still going to be that the distance from center is your center to vertex. Your B value is the center to what's going to be called a covertex. It's not called that.
What is it called?
I don't know. I honestly don't know. We could look it up. There is some fancy name for it. If you look at this, if your center is going to be at the origin, your vertex is the value of A. The value of B just goes the opposite direction. Okay? That's all it is. I don't call it, it's not technically called the covertex. It really has no meaning because it's in a region that the problem won't ever exist. So that's why I don't give it a real name. But if we call it a covertex, we'd understand what we're talking about. It's just the other spot. And just like we did before, the focus, the vertex is always looking at the focus. So the focus is further away, it's just further out. So to solve for the A, B's, and C's now, it's just also a little bit different. C is going to be the center to focus. And then your C squared value is A squared plus B squared this time. Now, if you notice the difference between the ellipse, when you had x squared over a squared minus y, or excuse me, plus y squared over b squared is 1. It was c squared, a squared minus b squared. And then in the hyperbola, it's c squared, it's a squared plus b squared. Notice that if it's an ellipse, to solve for c, it's minus, so it's just opposite sign. Same thing here, it's just opposite sign. So even in your calculators, when I told you guys about that whole app thing where you have the generic form of the equation, if you go to the, if you have it, yeah, exactly. If I go to the hyperbola, if you look at it, it tells you with the shift, which we'll talk about Monday. It's very similar to what you guys have been doing, and so far it doesn't seem like that's scary. When you deal with it, it doesn't tell you how to solve for your A's or how to solve for C, but if you just remember that the C squared term is going to be the opposite of that sign, the A squared and B squared, you'll be okay. Does that make sense? Plus, if you wind up with a C value that's not where the vertex is looking at, you know you're doing it wrong. Just a little trick. Okay. So let's just, for argument's sake, let's just jump right into a problem and just go for it. It really shouldn't be all that scary. So the hyperbola, if the x squared comes first, it goes left and right. If the y squared comes first, it goes up and down, yeah. Excuse me. And like I said, that little app there tells you, basically shows you what it is. So you just have y squared first, it's up and down. X squared is first, it goes left and right. Pretty simple. So, let's look at this. Let's draw the hyperbola given by the following information. And we're going to label everything. Yes. A value is just the first value. A value, B value, the first one is at A, the second one is B. What happens here is the X and Y change places this time, not the A's and B's. Gee, what do you think you're going to do first?
Divide by 36.
Divide by 36, good. So we have x squared over 9 minus y squared over 4 is 1. Yes?
How do you know when the y squared goes first and the x squared goes first?
It would be written 9y squared minus 4x squared. It could also be written as negative y squared plus x squared. So whichever one's negative. That's what we're asking. Yeah. Don't worry about it. A squared, is 9. Your b squared value is 4. Therefore, c squared is? 13, very good. A is plus or minus 3. B is plus or minus 2. C is plus or minus the square root of 13.
Oh, because we're plussing.
Yeah. Remember, like I said earlier, Abby, the way to remember that, if that's a minus, this is going to be a plus.
Okay.
Like yesterday with the ellipses, it was plus, it was minus.
Okay.
It just, to solve for c squared, it's just the opposite. So now you know everything we're centered at the origin. The x squared term came first, so which direction do we go? See, look at us, we can do this now. Gotta make the sound. Yeah, exactly. You don't get this humor in, like, biology.
Especially if they have just
I can't make it.
So, right now, what you do, yes. Oh, did you?
Wait, why?
I even. Seriously, I just looked at the thing and I said, oh, it goes like. Sorry. Thank you. I flipped the wrong way because I'm not paying attention. I was looking for my coffee and I was busy going and not looking what I was doing.
Where's your coffee?
No, yeah. Wait, how do we do it?
It's all the way
If
back.
x squared comes first, it means it's going left and right. If y squared comes first, it goes up and down. Here's what you do once you plot your vertex and your covertex. What I want you guys to do is to create a rectangle.
Does it have to be dotted?
Yeah, because this is just kind of like, because that rectangle isn't there. But what is there are what are called slant asymptotes.
Oh, yeah.
Slant what?
A slant asymptote,
How do you spell that?
T-H-A-T. A slant asymptote,
God, you
Oh my god.
well played.
it took a while to get muddled through there too. You're like, wait.
Same, I was like thinking about that.
Oh, I get it!
I said,
I'll show you. Anyway, what's occurring here with these hyperbolas is that there are what are called slant asymptotes. As you guys know, an asymptote is kind of like a region that a curve or a line or something like that is approaching but never will get there. And in this case, you have two of them. They are diagonal, hence slant. They go through the corners of your rectangle. Okay? Yeah. Asymptotes are always dotted, like a vertical asymptote is a dotted line. It's an approximate, it's a value that you don't hit. It's a region. We see a lot more asymptotes as we get into some, not polynomials, but we do logarithms, exponential functions. We'll see asymptotes with trig values, things like that. They're relatively simple. We'll have them polynomials too. It's not that difficult to work with. What happens here is that I'm going to ask that you guys figure out the equation of the asymptotes.
Like the slope triangle.
Well, not just the slope, but the actual equation of the line that's created by it. In slope-intercept form, okay? Now, what you're going to notice is that your slant asymptote today is going to have 1 point, or actually even tomorrow, you're always going to know 1 point, your center. The asymptote, the slant asymptote. I think it is. A-S-Y-M-P-T-O-T. I did that, right?
No.
You did that.
A-S-M-Y. A-S-Y-M. The slant asymptote. Okay. So what's nice here is when we draw this little rectangular box, you can easily find the slope. Since you're starting at the origin, you went up 2 over 3. I know the slope of that is 2 over 3. And today, I know, well, I could write the equation given 2 points, or I know that I have the y-intercept, don't I? What's the y-intercept in this case? 0. So the slant asymptote has an equation, and today only, slope of positive 2 over 3 or negative 2 over 3. There's 2 lines. You have y equals 2/3 x, bless you, or y equals negative 2/3 x. I'd rather you write it twice because when we do these shifts, they're not going to be, they're going to have the same slopes, but they're not going to be the same intercepts and stuff like that, okay? One of the, all right, to be honest with you, the main reason I'm going to have you guys write out the equations of the slant asymptotes is because some of you guys are on math team, and some of you guys might be taking the conics test. This is something they ask you on the conics test.
wait, what's on what?
So I'm just kind of preempting you guys to be better.
I'm not on the math team.
I know, but it's good.
I don't want to do that.
All right. The last thing I have to do is plot in my foci. My foci are at plus or minus c value of plus or minus root 13. Root 13 is more than the square root of 9, less than the square root of 16, so it's somewhere.
Yeah, sure.
Is it after it?
Yes, we have 1, 2, 3, so it's after it.
Wait, that's like a thing.
Now here's how you graph this. This is really cool. Hug your asymptote, go through the vertex, and hug the asymptote.
Oh man, that's so cool. That's so cool.
Hug your asymptote, go through the vertex, hug your asymptote.
Wow. Wait, I don't understand.
The only thing I did not label in here, well, we got to label our parts here. We had vertices at
No, that's a lot of
negative 3, 0.
Do we have to label it?
Yeah, I'd like you to. The co-vertices were at 0, 2, 0, negative 2. Foci were at negative root 13, 0, root 13, 0. And then we wrote the equations of the line of the slant asymptotes. So the hyperbolas have a little bit more going on for them because I'm going to ask you to write equations of the whole line. That's about it. Remember A, B's, and C's all stand for the same thing as they did in the past couple of days. All right? Let's try another one.
Hold up.
No, there is no, we don't worry about the directrix in this because the directrix would have to be equidistant from the foci to the vertex and backwards. I'm sure there is something there, but we don't worry about it. Yes, ma'am. Yes, square root of negative 13, 0 and 13, 0.
Those are all guys?
Not necessarily, because it depends on how far out your
Wait,
focus
so what was
is.
the slant?
That was an x squared one. Let's flip flop this. Let's make this a y squared one. So let's do y squared over 49 minus x squared over 81 is 1. Just so we get the idea of just seeing what it looks like going the other way. So if y squared came first, it's got to go up and down. I'm going to mark it up and down this time so I don't make a dumb mistake like I did last time. I know. Thank you. Delete those points. Hold it over your head. All right. A squared is 49. B squared, 81. C squared becomes 130.
Yeah, sure.
So this gives us an A value of plus or minus 7, B value plus or minus 9, C value of plus or minus, well, does 4 work?
Well,
No.
No.
Hold on.
They're all decimals.
Why do you?
Are they all decimals? You checking the calculator for us?
Yeah.
Cool. So it's just plus or minus square root of 130. Our center will be located at the origin, good old 0, 0. Our vertex, you can go vertical. So I go up 7 and down 7. A list here. Vertex 0, 7, 0, negative 7. Covertex goes left and right, 9. One of the things that I do, yeah, draw the box. One of the things I make sure I do when I give you guys, quizzes and tests and stuff on these things is that I will label out, center blank, covertex blank, vertex blank, foci blank, so that way you don't forget something. All right?
Here's.
I try. Don't tell anybody.
Don't tell anybody.
Do we have to draw like that X thing too every time?
Yes. The slant asymptotes have to be there because that way you know where to hug your asymptote for the curve.
You're right.
You have to know your asymptote from the hole in the ground. Thanks. He never really said that I was funny, so. The THAT was pretty good though. These just look really cool when you graph them. You got dotted lines and stuff and everything going on. Woo! You know, it makes you look really smart. Look at this math! You know. We got to put our foci in. Our foci would be at plus or minus the square root of 130. Well, square root of 130 is larger than the square root of 121, but it's smaller than the square root of 144, so it's somewhere between 11 and 12.
Yeah.
So here's 7, since this has got to go vertical, 7, 8, 9, 10, 11, 12.
Oh, no.
Hug the asymptote, go through the vertex. Hug the asymptote,
Okay.
hug the asymptote, vertex, hug the asymptote.
I did the wrong.
The foci, I'm just confused.
How to do the foci?
Yeah, like.
I approximated because 130 is between 121 and 144, so it's between the square root. It's square root of 121, which is 11, and square root of 144, which is 12. So it's somewhere between 11 and 12.
Oh, okay.
I'm just doing quick approximations. That's all I'm doing, just kind of get an idea, because now I just label it on my graph that my foci was at 0, root 130, 0, negative root 130. Okay, that's all I'm doing.
Okay.
Lastly, yes. Oh, sorry. She's kicking me up here. Lastly, I have to write the equation of the line of my asymptotes. My asymptotes have slopes of, well, I went up 7 over 9. So it's going to be y equals 7 over 9x, and y equals negative 7 over 9x. I'm not trying to give too many of them. Okay. They look cool, aren't they? It'll be A over B. If it's up and down, then it's B over A. It's the other way. But it's just as easy to count. And that's the whole idea by plotting with the rectangle. It's very easy to see it. Yes, sir.
All that stuff.
Yes, sir.
A lot of stuff.
There's a lot of stuff, but is it really? I mean, you've been doing the same stuff for the past few days, so I mean, it's not like.
It's just like time.
It
It's
just
takes up a lot of paper. It's time problem. That's really
One cup on the front, one cup on the back.
I use it once a
I want to make sure I have this right. I don't think I need to show you guys how to do it via focus and vertex and all that. I figure I'll let you decide on your own.
19 through 41. Both eyes.
still a lot.
Tell me what?
I want her.
Yeah. Hey guys, listen up. These are the 19, 21, 23 is write it in standard form. You don't have to graph it. Yeah. Yeah, they're all odds. The 25, 27, 29, you just have to, you don't have to graph it, it's just where are the parts. There's only 1, 2, 3, 4 of them that are the graph. And then, what's that? Yeah, it's really not that bad. It really isn't, okay? Whichever one they tell you to graph, I don't remember. It tells you.